Hello and welcome back. So in this video I'll be talking about forecasting in Excel. Who can benefit from this? Executives who are usually in the boardroom talking to AI teams who don't have like the full background in data science, data scientists learning forecasting methods, etc. I'm assuming no prerequisite other than like high school knowledge. Problem statement. Let's say I have a series of numbers and I'm trying to forecast what comes next. Very simple. Like 2, 4, 6, 8, and then the Fibonacci series, for example, every number is the addition of the previous two ones. Or could be more complex. I have a series of tables of columns, okay, like month 1, this is what I have, month 2, this is what I have. Or in a process, step 1, this is what I have, step 2, this is where I am, etc. And then I want to forecast. I'm here now, what should come next, okay? Of course, usually there are plenty of AI machine learning methods, ARIMA, Profit, XGBoost, LSTM, random forest. But here we'll talk about intuition and we'll take it analytically. We'll see what happens under the hood so that we see better how to interpret it, control it, know the mechanism behind it. Now, let's say I have 3 columns, C1, C2, C3, and then I'm forecasting what should come in C4. Let's decompose it into some matrix algebra, like having 2 by 2 matrix here, C1, C2, and then 2 by 2, C2, C3, okay, M1 and M2. Now, what do I need? I need a matrix such that if I multiply it by C3, I obtain C4, okay. Before that, the matrix, let's call it transition matrix, T, if I multiply it by M1, I should obtain M2, and this is how I can measure. All right, so T times M1 should be equal to M2. If we want to solve this with simple math, I should divide by M1 both sides, and I obtain T equals to M2 times the inverse of M1. That's it. And in matrix algebra, it's exactly this. To verify, I should multiply T by M1 to obtain M2, T by C2 to obtain C3, and then T by C3 to obtain C4. Let's take a very simple numerical method here, numerical example. Just take series like 3, 4, 5, 9, 16, 25, which are the square of the above, and then I should forecast this. Okay, very good. Let's take it into Google Sheets. So the inverse of M1, okay, is very simply stated here. M equals the inverse of M1, and that's what I obtain. Google Sheet will do it for me. And then T is the multiplication of this inverse by M2, okay, or M2 times the inverse. Okay, so I calculated T. Now I verify. I multiply T by M1, I should obtain M2. Here is the M2. It's exactly the same. Now the test, okay? I multiply T, this transition matrix, by C3. I should obtain C4, and this is what I obtain numerically. Very, very close. Under 3% error, which is interesting. If I take another example, like couple of columns, take 3, 4, 5, 6 series, and then x squared, the 1 over x, x cubed, these are non-linear, even the Fibonacci. And then I forecast, okay, here the M1 would be this matrix, the M2 would be this matrix. I do the same as above, and the error I obtain is under 1.5%, which is interesting. Now, if I want to systematize this, here is the Python code. It's in Google Colab. M1 defined M2, and then this is the inverse, simply inv in Python, or pseudo inv, which goes through matrix decomposition, singular value decomposition, which solve if there is linear dependence between the lines that I have. in my numbers, and then it will render my my transition matrix. Okay. Now, if you need this code, please write it in the comment and you will receive it. Now, the pseudo inverse, yeah, we talked about it. It can help a lot. It's a very nice trick. How about this was for matrices, right? Like for tables. Okay, matrix is just a fancy name or a mathematical name for a table of numbers. What if I had just a line of numbers? Okay, I can transform it into a table. How? I just, take this line and then I cut from here down and then paste it here. And then I cut from here down and then paste it here. And now I have this matrix. Okay. And I can apply the formalism. It's a simple trick. Where to apply this? Sales forecasting, demand planning, finance forecast, cash flows, customer churn prediction, marketing, operations, supply chain, predictive maintenance, healthcare, patient volume, admissions, outbreaks, energy and utility, traffic and mobility, and weather, obviously. So why analytical? It's because of the interpretability and accessibility of the information. The inverse has an exact formula. One can trace back exactly why the inverse is small or big and why this value is small and big, or how to increase it, for example. This is very beneficial for executives to correlate what should I do in order to increase this or reduce that. Of course, now for the more nerdy or have some mathematical skills, one can decompose this T matrix into eigenvalues, eigenvectors, and then see the distribution of those eigenvalues in the imaginary space on the unit circle, and then correlate that with the accuracy. Very, very nice exercise. And this is very good start for those who use Kalman filters. They will know it's about autopilots like landing, airplanes. In robotics, it's used for stability, etc. Now, more recently in drones, driving on their own, etc. Now, another nice example where it can be used, the Granger causality, which is like lagged causality, something that happened like in the past. If the price of aluminum goes up on month 5 and then the ticket, for example, or like the stock price goes down in month m+1. So something that's happening before, and even could be something correlating, like some event, call it C, happens at month M, and at month m+1, an event E, okay, happens. So if this formalism sees it like twice, 3 times, then if you ask it, okay, I'm having again, this event is happening at this month, it should predict for you here what should come next, which is interesting. So finally, credits when it's due. Big thank you to Nassim Talib, Greg Sanderson, Luis Serrano, Steve Brunton, and many other friends from whom I learned a lot. And if this video was helpful for you to introduce you to some concepts that you want to use for any development and you want to cite, this is how you can cite us and link this exact video. Please, if you found this beneficial, share, like, comment, and subscribe, and I'll be happy to reply to your questions.